In example 4 here, we want to continue applying our ideas of proportionality to an image that looks like this one. So it says use proportional segments of transversals. This question states that a developer is looking to purchase lots 18 and 19 on the lake and wants to determine the length of the property's boundary that runs along the lake, a measurement known as frontage. Find the lake frontage for lake lot 18 to the nearest tenth of a yard. So they want to know how long is this section X here. Well, if I go ahead and I draw out my triangle here, like we've seen a few times, and I connect it, the two sides, with a line that's parallel to the bottom, what I get is I get these proportional segments. So once again, like if this is 1 and this is 3, this could be 2 and 6. There's kind of this proportionality. So I made, for example, a proportionality of a 1 to 3 ratio. Now, it doesn't matter how many times I slice this up, this will always the segments over here, like, the segment between these 2 points, the segments are going to remain proportional. So for example, this one could be something like this: 1 to 3 to 2, and maybe this side is 2, so this would be a 6 and a 4, right? The relationship between that side to that side, the 1 to 3 ratio, is the same as the relationship between that side and that side, a 2 to 6 ratio. 2 to 6 is the same as 1 to 3. Okay, so what we have in our picture here, you might not see the triangle immediately that we're dealing with, but what it is if you continue these dotted lines down this way and these dotted lines down this way, then you get your triangle. We're just not showing the full triangle. We're showing kind of a chunk off the top of it. But the proportionality should stay the same. So whatever the proportion is between whatever the proportions are that we can notice will be true throughout. So I guess there's actually two different ways to look at this. We can say there's a proportionality between these two numbers. We multiply by 3, and that proportionality stays true here. We multiply by 3. Or you could do it a different way. You could say between these two numbers, there's a proportionality of times 2, and that's the same as between these two numbers times 2. Okay, so there's not a certain direction that we need to notice what these proportions are. In the problem up here, if we draw this one out real quick, we've got a few pieces of information. We've got 96.5, 102, 120, and x. Okay, so what I would suggest is that there's probably two different ways that I can write out these proportions. I can think of, this proportion. We have a 102 to 120 ratio, and that should be equal to the ratio between these two. So we can say equals 96.5 over x. Or if we wanted to, not draw attention to the proportionality in that direction, if we instead wanted to say, what is the proportionality this way, we could say that a 96.5 ratio to 102 should be equal to x over 120. We can do the comparison that way. And we're going to end up with the same thing in the end. So either way, we'll solve for the same answer. So if I wanted to solve for x over here, I would, for example, multiply by 120 on both sides. And then once I've got whatever that simplifies to, I know my x value. Over here, it would take kind of an additional step. In order to get x out of the denominator, we'd have to multiply by x on both sides, which would cancel out over here. Then we would need to multiply by 120 on both sides in order to get rid of this on the bottom. And we'd have to divide by 102 on both sides in order to get rid of this number on top to get our x by itself. So then we'd be multiplying 96.5 by 120 and dividing by 102, which, if you look over here, 96.5 times 120 divided by 102, it's the same exact thing, right? It's just a different order of steps to get there. One of them just requires a few less steps than the other. But it doesn't really matter how you set it up originally, you end up with the same answer. The product of these two divided by 102. And if I had to guess without doing the calculation, since 96.5 is a little bit less than 102, I would guess that this answer is going to be a little bit less than 120, maybe 110 or so, something like that. Okay, so that's how you would approach example number 4.